welcome back to my math YouTube channel. I'm back here with another example on using the chain rule. So guys, we already started learning about the chain rule. We already know the product rule, the quotient rule, the power rule, and now we're going to try and see how we can use these rules or combination of these rules to solve or to evaluate the derivative of a function of this type. So guys, here we can already see that there is a product going on between this function and this other radical function. So in this example, first we cannot just directly start using the chain rule. Guys, first one has to use the product rule and then we may have to use the chain rule. Okay, so in this example, the first thing that we have to do is we have to treat this as a f function and this as a g function, and we can see that it's a product of two functions. So using the product rule, we know the product rule is f prime, the derivative of y on the left hand side is same as f prime g plus g prime f. That is my product rule. Using the product rule, we are going to just apply the product rule on this particular function. So we have to take the derivative of this. So I'm going to basically write some steps here: d over dx of x plus 10 to the power 3, and then I just have to multiply by the g function, and g function is just the radical of 1 minus x squared, and then I have a plus, and then I have to take the derivative of the g function, and in this case I'm first just going to rewrite the steps and then I'm going to write it. So guys, I'm going to rewrite or just write this radical in terms of an exponent. So I'm going to write it 1 minus x squared raised to the power 1/2. Why we want to write it like this? Because we want to write everything in the form x to the power n so that we can use the power rule. And then it is times the just the f function by itself, which is x plus 10 raised to the power 3. So in this example, first one had to use the product rule because we could not directly use a chain rule on this whole function because it's a product of two different types of functions. So first we use the product rule. Now we have this in front of us. Now we can just see, like, for something like this and something like this, one has to use what we call as the chain rule. But guys, keep in mind, chain rule is not so complicated. It is still using the power rule and then multiplying by the derivative of the inner, okay? Because using the chain rule on these type of functions, it's basically composition of different functions. So one has to do some extra step or steps depending on how big the composition is. So guys, in this case, we are going to treat this whole thing as a big X. So x to the power 3, how would you find the derivative of that? Just simply use the power rule. Using the power rule, it's going to be just n, x to the power n minus 1, so 3, and then in the parentheses I have to write this whole thing, x plus 10 raised to the power n minus 1, 3 minus 1 is 2, and then we have to multiply by the derivative of the inner, which in this case is the derivative of x plus 10. What is the derivative of x? It's just 1. What is the derivative of 10? It is 0. So it is basically multiplying by 1, which is not going to really matter here because multiplying by 1 is not going to change anything. I'm still writing it because we are just like doing these examples. So I want to make sure that everybody knows what is actually going on here. And then I don't have to do anything with this. All I have to do with this is I just have to rewrite this. And then guys, let us see what we have to do with this guy. Again, this first one, for this first function right here, we have to find the derivative. We don't have to do anything with this. Guys, to find the derivative of this, we have to use the chain rule, which in turn is like using the power rule and then multiplying by the derivative of the inner. So for this, I'm going to treat this whole thing as a big X. So it's x to the power 1/2. So I bring the 1/2 up front. Then it's 1 minus x squared raised to the power n minus 1. So it's 1/2 minus 1, which is going to be just negative 1/2. But then I have to multiply by the derivative of the inner. Derivative of 1 is 0, so we don't have to worry about that. Then there's a minus and x squared. Derivative of x squared is just 2x. So it is going to be times negative 2x. Guys, there's already a negative, so we got to keep that negative. And then times, what do I have? X plus 10 whole to the power, x plus 10 raised to the power 3. Guys, my goal here is to try to show you many different variety of examples so that you can see like how the process works and how we apply these different rules to evaluate the derivatives, and you become confident looking at these and trying these on your own. Let us see if we can simplify. Maybe we can simplify one more step. So guys, y prime is going to be 3 times 1 is 3, so it is just 3 times x plus 10 raised to the power 2, and then square root of 1 minus x squared. That takes care of that half. And then guys, right here on the other side, this 2 and this 2 will cross out, right? this 2 and this 2 crosses out, and then I'll have a minus x, so I can just take that minus here, and then I can write it as x times 1 minus x squared raised to the power negative 1/2, and then there's x plus 10 raised to the power 3. So this is like my final answer or for the derivative of this function. Guys, usually, we don't like the negative exponents. So sometimes what I see is instead of writing this with a negative exponent, we take it downstairs. So if I take this thing downstairs, and let us actually do that right here. So if I take it downstairs, what's going to happen? This x right here stays, right? The minus is already from here. And then guys, when I take this thing downstairs, it becomes 1 minus x squared raised to the power 1/2, because we know that from the basic properties of the exponents. When I take it downstairs, this negative exponent changes to a positive exponent. And guys, we already know that raising to the power 1/2 is same as the radical, putting the radical. So sometimes you may see that the final answer is in terms of the radical. Guys, if you put it raised to the power 1/2, that is also correct, but you can also change it to a radical. It depends on what the answer looks like, or what you want the answer to look like. Whether you leave it like a radical here, or raised to the power 1/2, or even like leave it upstairs with negative 1/2, guys, I think the answers are they're all correct answers. But sometimes we don't prefer negative exponents, so then in that case you bring it downstairs, it changes to a positive exponent. So guys, this is example 3. I'm still going to show you more examples because there's different variety of examples. I'm trying to cover as much concepts and as much things I can cover in this section. But keep in mind, just by looking at this function, we can see that it's a product. So that's why we are using the product first, and then we are using the chain rule. Okay. So number 3 is done, guys. I'll see you in the next example, where I think I'm going to do something with the quotient rule and a combination of quotient as well as the chain rule. Till then, take care.